Welcome to this tutorial on Torque 2021. Let's tackle this question. The rider bikes over a 4-meter long bridge and stops 3 meters from the end. This is all labelled on the diagram below, as you can see in pink that I've just highlighted. The bridge has a uniform mass of 700 kgs. The combined mass of the rider and the bike is 85 kgs. Part B, we're asked to state the conditions required for the bridge to be in equilibrium. So what is the meaning, what is the definition of equilibrium? Well, equilibrium occurs when all the forces are balanced. So what are the forces that are occurring in this instance? Well, since this is a torque question, we've got torque, force, which is acting. Torque is a turning force. And torque can cause the direction of something to go in either a clockwise direction or an anti-clockwise turning direction. So for equilibrium to be achieved, all the clockwise torques around a pivot point have to be balanced with all the anti-clockwise torques around a pivot point. Other forces which are acting on the bridge are some upward forces and some downward forces as well. So the upward forces in this instance is provided by the support forces A and B on either end, and the downward forces are the biker's mass, the combined mass of the biker and his bike, and the center of mass of this whole bridge. So, considering all of this, what is needed for equilibrium to be achieved? Well, I've written them over here. Moving on to part C. Draw labelled arrows to represent all the forces acting on the bridge. So, as we've just discussed, we've got the centre of mass, which is the halfway point of this bridge, and it's at 2 meters. I'll just write that here. And at this 2 meter mark, we've got the mass of the bridge acting. It's the centre of mass. So I'll draw a downwards vector over here and label it centre of mass. So this is the force of the centre of mass. If we were to calculate this, we may as well do it as we go. Force is equal to mass times acceleration. And so the force of the centre of mass of this bridge would be its mass, which is 700 kgs, times the acceleration due to gravity, and we get a value of 6,860 newtons. We've got the force, the downward force of our biker, and the mass, let me just label this first. We've got the force of our biker, and the mass of the biker and his bike is 85 kgs. So if we're calculating the force is equal to mass times acceleration. So we know that we've got the mass of 85 kgs times acceleration due to gravity. Plugging that into your calculator, you get 833 newtons of force provided by this biker and his bike. What other forces are acting on the bridge? Well, as I've discussed, all the downwards forces have to be balanced out by upwards forces, which are provided by support force A and support force B. The question doesn't actually give us information on what the value of these forces are, but I'm sure we're going to have to calculate these later. However, I will label them for now, support force A and support force B. Next question. We need to, according to part D, calculate all the values of all the forces acting on the bridge. So, what are we going to do here? Well, first of all, we need to pick a pivot point. So it's going to be either support force A or support force B? I think I'm going to pick support force B as my pivot point because we can measure the lengths of everything from support force B very easily, okay? So this is my pivot point. So since that's my pivot point, I'm going to have to work out the forces of everything around this point. We've already got the force of our centre of mass and the force of our biker, but we need to work out the force of our support force A. So now that I've picked a pivot point, the next thing I have to do is understand that all my clockwise torques have to equal my anti-clockwise torques. So I'm going to make a table. So we're up to part D now. I'm going to make a table. So I've got all of my clockwise torques and they have to equal my anti-clockwise torques. So what are my clockwise torques? If we look back at the diagram, around pivot point B, let's have a look at all these forces and what way it would cause the plank to turn, what direction. Starting with support force A, let's have a look. If we were to follow this arrow around the pivot point B, it would twist this whole bridge into a clockwise direction. If we were to look at the torque provided by the biker and his bike, follow this arrow around the pivot point B, it would be a anti-clockwise torque. What about the centre of mass? Pretend that this bridge is going through the floor or the ground, okay? And so if we were to follow this arrow around pivot point B, it would also provide an anti-clockwise torque. We don't consider forces acting at support force B because we've made it our pivot point, okay? And so now that we've established what our clockwise torques and anti-clockwise torques are, we can fill that out into our table. Okay, so our clockwise torque in this instance is the torque of our support force A. Are there any other clockwise torques? No, there isn't. So we can continue on and fill out our anti-clockwise torques. We've got the anti-clockwise torque of our biker plus the anti-clockwise torque provided by our centre of mass. To work out torque, the equation is T equals force times distance, and that's the distance away from the pivot point. So now that we know our anti-clockwise and clockwise torques, what we can do now is flesh out these torque equations for each component. So if we were to flesh out the torque calculation for support force A, okay, it would be the force of support force A, okay, times its distance away from the pivot point, times its distance away from the pivot point. We've got the torque equation for our biker, so what is that going to look like? Well, it's going to be the force of our biker times the distance away from the pivot point. To flesh out the torque equation for our centre of mass, it would be its force times its distance away from the pivot point. Now that we know what our torque equations are, all we have to do now is we have to substitute the values into this equation. So starting off with our clockwise torque equation, what is the force of support force A? We don't know that yet because that's what we're trying to figure out. What's its distance away from our pivot point? Well, as you can see, the distance away from support force A and support force B, which is our pivot point, is 4 meters. So I can plug that into the equation. Moving on to the torque equation of our biker, the force provided by our biker is calculated to be 8.33 newtons. It's just 833, my bad, times the biker's distance away from our pivot point, which is 3 meters. Next, we have the torque equation for our center of mass of this bridge. And we know that the force of our center of mass, we've calculated it earlier, is 6,860 times its distance away from the pivot point, which is 2 meters, because the center of mass is the center of 4 meters. So we know that from the middle of the bridge to the end must be half the total length. So it's 2 meters. Wonderful. Now what we can do is, since we've got this equation, we can simplify it. First, let's simplify this part here. I got 2499 plus, let me just put that in brackets so you can see what is going on. And then let's simplify the torque equation for our center of mass. So I've smushed those values. Now we can simplify it further, and what you get is 16,219. And so now we have the simplified equation, support force A times distance equals 16,219. And now what we can do is rearrange this equation to find support force A. So to get support force A on its own, we need to divide this whole thing by 40, because currently it's being times by 40, so the opposite of times by 40 is divide by 40. So that means whatever I do to one side of the equal sign, I have to do to the other, because it's like a mirror. And what I'm left with is support force A equals 16,219 divided by 40, and that, everyone, should equal 4054.75 newtons. And so that's the answer for support force A. That's the amount of force, upwards force, it's providing to help balance out those downward forces. My goodness. Okay, so we've worked out support force A. So we need to work out support force B over here. How are we going to do that? Well, what we could do is we could make support force A the new pivot point and work out everything around it. But we're going to make use of our second equilibrium rule over here. All the upwards forces must be balanced with all the downwards forces. So I'm going to go ahead and make a new table. So all the upward forces must be balanced with all our downward forces. And the equation for force is F equals ma. Let's not forget that. And so let's try look at our diagram over here and figure out what our upward forces are. So our upward forces are going to be our support forces. So we'll add that to our table here. Support force A plus support force B. What are our downward forces? We've got the force of our biker and the force of our center of mass downwards. So we'll add it to this side of the column. Got the force of our biker plus the force of our center of mass. So luckily we've done a lot of the work already, okay? And so support force A is a mystery to us. Support force A is a mystery to us. But support force B is not, because we just literally worked that out. And that's going to equal all our downward forces. So what is the force of our biker? We worked that out earlier to be 833. 833 newtons. And then we've got the force of our centre of mass, which is 6860. So now what we can do is simplify this thing. And so we'll start off by simplifying this side, and that is going to equal 7,693 newtons on this side. These are all the downward forces. And on this side, we cannot simplify it further. But what we can do now is we can rearrange to find support force A. So how do we do that? Well, currently it's being added to 4054.75. So to get rid of that, we have to minus it on that side. So let's go ahead and do that. Minus 4054.75. That means we have to minus 4,054.75 from this side. And so what we're left with is support force A equals 7,693 minus 4054.75. And so what you should get once you enter that into your calculator is 3638.25 newtons. And that is the value of support force A upwards. So add this to your diagram so that you can show all the forces acting on the bridge. And that's that question done.